Good afternoon, everyone, and welcome to Network 2020's webinar today, when we will be talking about cooperation in space, all things space. We have a wonderful panel lined up today, and the timing is quite good for this talk, as you will hear, because there have been some important developments in the international space scene. So before we begin, I would just like to briefly introduce Network 2020, as well as our panelists. I am Courtney Doggart. I'm the head of Network 2020, and we are an inclusive international community, and we're really focused on bridging the gap between the private sector and the foreign policy community. And we do this in a number of different ways, but we also have webinars such as these, private discussions with leading foreign policy experts. We do research trips abroad. So please do check out our website and YouTube channel and other social media for more information. With that, it is a pleasure to introduce our panelists today. So we have, first of all, we have Therese Jones, and she is Senior Director of Policy at the Satellite Industry Association. We also have, I believe we have Scott Pace. He is the Director of the Space Policy Institute and Professor of the Practice of International Affairs at George Washington University. And next we have Dr. Jessica West, and she is a senior researcher at Ploughshares. So welcome to the three of you. Thank you so much for joining us today. Space has been in the news for everyone this summer for many reasons that we'll get into later on, but I know that there have also been a lot of developments on your front as well. And in doing research for this program, I was actually shocked to learn about some of the statistics in terms of activity in space. And so I think that everyone who's listening will hopefully come away with some new information. So we wanted to start just laying the groundwork a little bit. More than 30 spacefaring nations have emerged in recent years, and 84 countries currently operate satellites above Earth. So there's this whole explosion of space actors that are shifting this dynamic of astropolitics. So Scott, turning to you, who is leading, and I don't even know if we use this term anymore, the space race today, and who are the major players on the horizon, both in terms of governments, but also, as we've all paid attention to this summer, there are a lot of commercial actors, and so how would you describe that breakdown between military and commercial applications in space?
Well, sure. I think the first thing I'd say is we've often said is space is characterized by increasing democratization and globalization. Globalization in terms of more and more countries involved in space. The UN Committee on Peaceful Uses of Outer Space is now up to 100 members. And I assure you they are not all there because they watch Star Trek. They're there because they see practical benefits from operating in space and geopolitical concerns with space. So it's an important place. So it's one of the largest UN technical committees. We're also seeing increased democratization. More and more private sector entities and even NGOs and universities are capable of going into space and operating there. So it's not something the province of governments alone anymore. So those are sort of the two really big trends. Now, space is a lot of space technologies are dual use, meaning they have both military and civil applications, not just rockets, but also things like remote sensing, satellite navigation, communications, even environmental monitoring can have dual use applications. So what we do in one sector kind of bleeds over into another. If you look at who sort of the major space powers are, essentially it's the ISS partners plus China, with a really an uncertain future with Russia. So you have some new players like the United Arab Emirates, for example, who is becoming more active. You have regional developments in Latin America becoming stronger. And you see, of course, a growing South Korean space development. But primarily it's the space station partners and China and Russia. Now, of course, Russia has been a partner with us on the station since the end of the Cold War. But that seems to be changing, and it's changing not only because geopolitics is a bit different, but also because their own capabilities are questionable. We've had a number of problems aboard the station arguably from aging hardware, but the Russians are certainly very, very sophisticated. They have a lot of operational experience on a one-to-one basis. They're great to work with, but the geopolitical relationship is bad, and their own economy has not been doing well, and their space capabilities are increasingly in trouble. In contrast, the Chinese are growing, have been growing, demonstrating more and more new capabilities all the time. And there, the geopolitics, of course, is bad and getting worse. But you know, space may or may not be another area of confrontation. They're doing a number of things that are very worrisome. And on the other hand, they've been doing things that are not worrisome and which are impressive. Their space station, I think they had the first female EVA spacewalk for them. They're looking at lunar plans. So there are a number of areas where we have the potential to maybe do cooperation with China, but again, it's against the backdrop of worsening geopolitical relations and increasing military concerns, not just in space, but also from their nuclear and conventional forces.
All right, great, thank you very much. That's a very helpful introduction to the lay of the land. One other topic that has been on a lot of people's minds recently has been the environment, because we have a lot of world leaders meeting in Glasgow. So this idea of sustainability is very much in the air. So switching that to space, applying that to space. Jessica, there was a letter that you helped draft, the Outer Space Institute letter, urging the UN General Assembly to consider a treaty banning anti-satellite tests. And you cited a statistic that surprised me, which was that the number of active and defunct satellites in orbit has grown from 3,300 to over 7,600 in the last decade, with the potential of as many as 100,000 active satellites within the next 10 years, which to me just seems, I mean, what an incredible leap. So can you elaborate on why this is a growing problem and what kinds of issues we're looking at down the road if a sound policy isn't implemented?
Yes, absolutely. Let me first speak really briefly to the letter, because you led with that. And I'll just point out to the audience that this is a letter that is currently open for signature by anyone, including people watching today. It's online and you can check it out and add your name if you're interested. The focus of this initiative is really to promote an international ban on kinetic anti-satellite testing. Kinetic weapons use hardware such as missiles to hit and destroy objects in space, which creates debris that spreads out from the impact and pollutes the surrounding environment. So the idea of banning this kind of activity sits at that intersection of space security and arms control issues on the one hand, and what we're going to talk about now, space sustainability. The reason why people believe the ban is becoming so urgent today is really driven by the safety and environmental concern. Because as you pointed out, there's been a huge increase in the number of satellites operating in space, particularly in the orbits closest to Earth. And it's only predicted to continue to increase at an even faster pace. The numbers really are mind-boggling. I remember when I first started working on space issues and tracking the number of satellites in orbit, and I think there were just over 1,000. And then it was mind-boggling to think about there being maybe 4,000, a four-fold increase. And now we're talking about tens of increases and even 100-fold increase in just a few decades. And this heavy use of space brings a lot of benefits. We're creating many new capability and services that are available to people all around the world, things like space-based internet. But it brings challenges, and debris is a big one, and that's the focus of the international letter. Unless intentionally deorbited, objects that we place in space stay there. And so you can imagine having car accidents on a really busy highway and not having a way to clear up the mess and the kind of problems that creates for safety and sustainability. The science behind this letter indicates that low Earth orbit will become so busy that even a single piece of unnecessary debris that is created by an action such as a weapons test is just one too many. Speaking of car accidents, the potential for accidental collision between satellites is another concern that's getting greater attention and spurring calls for more rules and better management of space traffic so that we don't have accidental collisions. But it's not just debris. Light pollution is another challenge. Satellites are very bright, and we have thousands of more of them whizzing above us in the sky at night. And so this makes it difficult for regular people like you and I to see the night sky. It can have impacts on traditional knowledge and practices, and it makes it really difficult for astronomers to do their work when the view of outer space is increasingly obstructed. And finally, what goes up must come down. You know, satellites are composed of metal and batteries and chemical components, and most of them burn up in the atmosphere when they re-enter, but not all of them. And we really don't know what the impact of having so many more satellites re-entering each year might have on the environment. All of this isn't to say that our growing use of space is bad. It's good, and we're gaining tremendous benefit. But it points to the fact that it introduces other problems that we have to work out. Some of these have technical solutions, and others are a bit deeper, and they involve competing values and competing uses of space. And it means that we have to try to find ways to accommodate these kinds of conflicts and figure out how to do good in the long term for as many people as possible.
Wonderful, thank you. And if you'd like, please feel free to put if there's a link or information about that letter in the chat. I'm sure some people might find it of interest. Therese, continuing on this idea of sustainability, I think you've had the chance to look at this topic from a variety of perspectives. So how central do you think the concept of space sustainability is in terms of its being embedded in current space activities? And what actions by the private sector or governments can be taken to catch up with what you would consider to be acceptable standards? And kind of tacking on to that, what do you see the role of the private sector as being in terms of supporting sustainable space activities?
Thanks, that's a great question. So at SIA, we represent over 50 different space companies. So satellite companies, launch companies, ground equipment providers, and all of them see space sustainability as really critical to their business case. They recognize that if they pollute the space environment right now, they won't have business, a decade in the future, including the geo operators who have to launch satellites through this more congested low Earth orbit environment. So we've had a number of different working groups on these space sustainability issues, coming up with things like industry-led best practices on space sustainability that are meant to be a model for industry internationally, that talk about things like minimizing the creation of debris both on launch and in on-orbit operations, talking about the importance of timely communication with other operators to deconflict potential conjunctions, trying to deorbit or move your satellites into a graveyard orbit as quickly as possible. So there's a lot of discussion on this from an industry standpoint in terms of best practices, but we've also really closely been working with the government on this issue. So the Space Council and in the Department of Commerce, there's an Office of Space Commerce that's working on what they call an open architecture data repository, which is seeking to move the function of tracking space debris has traditionally been within the DoD. And there's a movement within the US government to move this effort over into the Department of Commerce, because right now, for the first time ever this past year, we had more commercial satellites on orbit than government ones. And that fraction is just going to continue to increase. So we really want commercial actors to be able to input data into this architecture, not just from the US, but for it to be internationally acceptable. And then also, cooperate across governments to make space data more reliable and accessible. A number of our operators are working with, it's called the 18th Space Control Squadron, on modeling the effect of their proposed constellations and trying to minimize debris creation that way. And I should say companies, not only are launching satellites and they're trying to plan debris mitigation, but they're also working on new and innovative technologies, such as being able to do automated maneuvers of their satellites if they can get a conjunction warning. They're also working on technologies like active debris removal, so being able to, attach, a grappling hook to a satellite on orbit and be able to maneuver it, or other such capture technologies to mitigate this. But the piece that's really the most difficult one, I think, is the international geopolitical one. Already talked a little bit about Russia and China, but on an international stage, there are a number of countries, including Russia and China, that really think it should only be state-to-state diplomacy on these issues. And that's ignoring this really big commercial sector that's booming right now. And if we only have state-to-state cooperation on these issues, I think we're going to run into a lot of future problems on oil debris.
Interesting. Thank you, Therese. And that leads us nicely into just sort of back into where Network 2020 likes to often talk about, which is on the foreign policy side of things, and on the geopolitics of everything. So Scott, turning back to you and kind of picking up on a thread that we were talking about before, in terms of what's happening in space, reflecting some of what's happening on Earth. China has rapidly expanded its presence in outer space with in both the civil and military areas. So what do you see driving China's space ambitions? And maybe you can even elaborate on Therese's point earlier, where they saw only government-to-government collaboration or diplomacy on some policies. So I'd love to hear a little bit more about that and what we can expect for them in the next years or so.
Well, to first order, I mean, China is doing things in space for their own national interest for a number of perfectly understandable reasons. They see it as increasing the prestige of the Chinese Communist Party. It's part of Xi Jinping's desire to, grow the power and visibility of the Chinese of China. They use it to encourage younger people to go into math and science and STEM education. They use it to increase the quality of their supply chains, because to build things to quality levels for spacecraft is demanding, and so it helps there. It teaches system engineering skills that, of course, have dual use benefits for weapon systems. It gives them a diplomatic option to use with other countries. So if they're looking at resources, say, from overseas, they can offer space technology as part of that kind of trade. So there's a whole range of perfectly understandable reasons why they would want to have space capabilities. And I would distinguish between some things that are probably very much at the prestige end of things, like some of the lunar landers and space stations and so forth, where they are looking to do things that other people have not done. They're not looking at doing things that are just repeating what had been going on 50 years before. For example, the lunar lander that went to the far side of the moon, something that we hadn't done. We were capable of doing it, we just didn't do it. They did. They're looking to find areas that are unique that they can, kind of claim for themselves, again, which is understandable. And those don't by themselves cause me a lot of concern. I've actually found in discussion of space resources, for example, the Chinese to be very pragmatic and in many ways aligned with some of our thinking on use and utilization of resources in space and what we'd have to do that safely. So it's not necessarily an area of conflict. On the other hand, their behavior in other domains, cyberspace, South China Sea, potentially even the Arctic regions and Antarctic regions, make it very clear that if they see their national interests threatened, they don't really care what anybody thinks. And so that's a problem. I think that if we look at the structures that we can, areas of commonality going forward, noting Jessica's point about the letter that was done, a way to start is to simply not continue to do things that people found objectionable, like blowing up satellites and causing lots of debris. After a lot of international criticism, the Chinese haven't done that again. After some criticism, I hope the Indians won't do that again. And so simply a test ban moratorium can be something that states can do now, which is the same thing that happened with atmospheric nuclear weapons tests. We didn't have a test ban treaty. We started with simply unilateral moratorium statements that states can do on their own. With regard to the commercial sectors being involved, there are a number of areas where I think we have some profound disagreements internationally, not with China actually as much with other states, including some in Europe and Russia. Parts of the UN are very uncomfortable with the idea of private sector participation. We, of course, are very comfortable with it. And yet, if you look at the space debris area, the most promising area, I think, for mitigating or even reducing this hazard is going to be operator to operator agreements, which has already been done in GEO. We need to do more of that in LEO. It is not going to be governments that are going to be able to do this. In fact, government tracking capabilities that are publicly releasable, in fact, are largely inadequate to mitigate and do the kind of debris management that needs to be done. And it's going to be operator-to-operator arrangements by the private sector that are largely going to do that, which in turn is in line with the US approach and many of our friends and allies of a bottom-up approach to dealing with new rules and behavior in space. That is, you look at best practices or things that ought to be done technically without a lot of political spin to them, and you try to codify them, which is what we did with the long-term sustainability of space activities, and which we are still now in discussion with for things like rendezvous and proximity operations. What we don't try to do is convene a bunch of lawyers and impose a top-down approach, which tends to be slow, tends to be rigid, tends not to be based on what people can practically do. One of the things that's been hopeful in recent years is people are more willing to look at, including, I hope, Russia and other countries, been more willing to look at behavioral-based limitations like don't blow things up, as opposed to things like bans against placement of weapons in space or preventing an arms race in space, which the US has usually found to be fundamentally flawed because no one can tell you what a weapon is in a way that makes any logical sense. So banning things that are subject to debate and hard to verify is a more difficult path than banning actions, which are easier to verify. And of course, is the subject of the letter that Jessica mentioned. So operator-to-operator arrangements by the private sector, bottom-up versus top-down kind of things, being behavioral-based, having a broader diversity of information running around through the OADR versus a centralized transnational or transgovernmental organization. These are kind of like the splitting points that you can find people on different sides. So everybody agrees with sustainability of space and needs to be preserved and not do anything dumb. But there are several different approaches that people take. And I'm hoping that our approach, the US approach, is slowly winning over converts.
Thank you, Scott. Following on that, Jessica, turning to you, can you elaborate on the importance of soft law and non-binding norms in current space law? So again, sort of like what Scott was saying about, hopefully other players joining in, but what are some of the non-binding norms, and is this enough? Or do you see the need for more enforceable policy in the long or even the short term?
Yeah, so Scott's given us a really great rundown of the way norms work. They tend to be bottom up, best practices, focused on behavior. They're things that we do because we ought to, not because they're legally required or because we know we're expected to do them. And I like to use examples like taking your shoes off in people's homes. These are norms. Giving up your seat to certain groups of people on the bus. These are all sort of social norms that we use to get along on a day-to-day basis when we're interacting with other people, and that same logic can apply at the international level to governance. And when it comes to norms, Therese is bang on. Industry leading on this. They have really spearheaded this development of industry-led best practices, and it's a model I think that can apply to other challenges of space governance, including, say, military activities in space. And there's a really great new development last week at the United Nations. The United Kingdom has been leading an initiative to try to address the underlying arms race that Scott alluded to in space from a behavioral approach and kind of from a voluntary approach, if you will. And so they've been arguing and trying to get states to get behind the idea of agreeing to norms of behavior in space, sort of like what Therese was talking about, military best practices, if you will, in an effort to avoid unintentional conflict. So not doing things that make other states worried and react in an aggressive way where you find yourself in an escalating conflict, and not to do things that might be dangerous and harmful to other operators if that's not your intention. And I think 165 states last week at the first committee of the United Nations in New York, where you are, voted in favor of creating a working group to start developing what these behaviors might be from a bottom-up approach focused on practice. There were a few outliers. The no votes were Russia, China, Nicaragua, North Korea, Iran, and Venezuela. I think I hit all 8. But But I think it's a huge success and it's a big win, and it's building on a model that's been working elsewhere. We've also seen it on long-term sustainability. So we don't have laws against pollution in space per se. We have a commitment internationally not to contaminate the environment, but we've adopted voluntary rules related to debris mitigation that Scott pointed to, the long-term sustainability guidelines. And so it takes that idea and tries to move it forward in an arms control area. Is it enough? I mean, yes and no. Norms are really central to collective governance, and they're central to law. They often tell us how laws work in practice. And they're often the starting point for stronger measures of governance. So the United States has been a huge advocate and a leader of a normative behavior approach in space. I think earlier in our pre-chat, Scott called it the least bad and the easiest. They're kind of easy and they're kind of not. Are they enough depends on, are they followed? And that depends on content. Is the content adequate to deal with the problems that we have? And do we have enough agreement amongst players and commitment to adhere to the rules or not? And so that will impact whether or not they're sufficient. My own experience in arms control is that norms have been vital. We've started with norms in a lot of areas of arms control, norms of non-use of particular weapons, chemical weapons, biological weapons, landmines. And then over time, we found that we had to codify them into stronger agreements and build on some of the capabilities that Scott was talking to verify and to provide mutual assurances. So I see this as a huge win. But I also see it as the start of a long-term process and hopefully an ongoing international dialogue to try to build that joint commitment and to continue discussing these issues on a really practical level internationally.
Okay, great. Thank you, Jessica. So it sounds like there are a lot of positive developments in many senses in terms of what's happening internationally. Therese, turning to you on the commercial side of this sort of security dimension coin, where is the intersection of private industry and governments in the current situation? As we talked about, private industry operates a lot of satellites, more, I think, now than we were saying that governments operate. And they're really critical to our daily life and our ability to function as societies. I don't even want to think about how dependent I am probably on satellite technology. So what is the interplay between those industry players and governments in our own security?
Great question. So there are a number of security issues that impact commercial operators. Already touched a bit on the anti-satellite tests, but India blew up a satellite a few years ago, and they claimed it was a low enough orbit to deorbit the debris quickly. But actually, a number of our operators had conjunction warnings with debris from that test. And so that's an issue that's not only security related and geopolitical, but that really impacted the private sector. There are other issues like the inspection of satellites on orbit by other countries that have impacted commercial operators. And you never know, is it a space weapon? Are they just trying to get intelligence on the satellite? There aren't really norms around inspection of satellites in space that are well developed or that are consistently adhered to. And there's a lot of intellectual property theft from commercial actors as well. But cybersecurity is a really big issue. We have issues with potentially GPS being jammed or the signal being spoofed, so you're told that you're in a different location than you're in, and also jamming on the communications side as well. NIST, I think it was NIST, did a study a couple of years ago that said that the US would lose $1 billion per day if there were a GPS outage. Because GPS hits on so many different sectors, including it's very heavily used in agriculture to help farmers plant their crops precisely. And the private sector impacts of a major attack could be very large. And I think partially thanks to Scott's work on the Space Council, there has been an increasing effort from the government, the US government, to include industry in these cybersecurity issues. Space Policy Directive 5 was focused on bringing in the commercial industry to work on space cybersecurity best practices, and the Department of Homeland Security, which works on this, has recently formed a space systems working group because they recognize it's really important to bring commercial actors in, since not just the US government, but the broader US economy is really reliant on space systems.
All right, thank you. Thanks, Therese. We will now turn to the Q&A. So thank you, all of you, for a wonderful outline. I hope that this gave a lot of people in the audience plenty to work with in terms of questions. If you have a question, please put it in the Q&A box. I see we're getting a bunch already. Our first one, Jessica, is picking up on an earlier point that you made about this working group and trying to set up, rules of the road to prevent misunderstandings that could lead to conflict. So the person who's asking this question, once they mentioned that China and Russia said no to the proposal, you had mentioned a couple of other countries. What's behind that? What's your understanding of why they said no, and what are the implications of that?
Well, part of it is geopolitics. There's competition among states about who will lead on some of these issues, and there's different preferences. So China and Russia traditionally prefer a treaty approach, and they've pitched a number of treaties over the years, most of which are echoes of one another from about 1981 onwards, and they haven't gone anywhere. So the idea of the working group and the focus on norms and behaviors is try to sort of unstick this stuck conversation by taking a different approach that might be more productive in the short term and the long term. But some of the really specific objectives that were raised last week at First Committee in New York were, I guess I'm going to go with not enough. It's not sufficiently focused on preventing an arm race. It's not sufficiently legal, and it's not sufficiently focused on weapons. Some of those are straw man arguments. I think the UK has done a wonderful job of reaching out and trying to bring the community together on this. And one goal of the working group is really to reach across that divide between states who really favor a treaty and legal measures and states who don't, by saying, you know what, the discussions that we have, we might also come up with recommendations that will inform a treaty down the road. And so it's not just one outcome that we're looking at. It's really starting a new conversation that will bring momentum to the discussion of arms control in outer space. And I think that was terrific. It really speaks to an underlying interest of the majority of states. But of course, to work, we need to bring these big players, as Scott mentioned, together. We need to have everybody on board. I'm actually optimistic. Both Russia and China and Iran presented good faith responses to the initial process last year when states were asked to submit their views on activities that they find threatening or reassuring and what the opportunities might be for moving forward. So there was good faith participation, even if they weren't 100% behind the process. And we've seen that vice versa in other forums as well, where maybe it's not the first preference of states, but they participate in goodwill. And I'm really hoping that that will continue, especially if we have an eye on how this might lead to behaviors, but also, further discussions on treaties down the road. But it requires efforts on both sides to try to find that accommodation and find where the mutual interests are. But there are lots of mutual interests: debris, ASAT testing, I think transparency measures, so things that the commercial industry is talking about with providing notification before events, having better lines of communication so that you don't end up in a bad situation with another operator. These are all ideas that were commonly coming out of the responses that states shared last year. So there's really great, I think, momentum already that we can build on.
Okay, fantastic. That's good. It sounds workable. Very positive. Scott, this next question I'll give to you. So the questioner is asking, as you mentioned, we're often thinking about the bigger players when it comes to space: US, Russia, China, India, and perhaps Europe to some extent. So what is the role of developing countries? And this person wants to know about African nations in particular. What are you seeing on that front?
Sure. Well, there's a couple of different ways developing countries are important. I had spent about 10 years going to the ITU, dealing with spectrum issues, and there it's a case of one nation, one vote, and so you have to persuade regional groups, both of the technical as well as political merit of your proposals. And I found that there was a lot of commonality between U.S. interests and those of developing countries in space areas, because space was infrastructure. And so one of my tasks was protecting GPS spectrum. And I often had some difficult discussions with our European friends and allies who sometimes had different industrial policy objectives. But I had perfectly wonderful discussions with many developing countries in Africa, Asia, Middle East, Latin America, because they knew that if GPS was interfered with, they would be in trouble. Aircraft would have difficulty landing, ships would have difficulty navigating. So communications, remote sensing, navigation, all of these things, infrastructure are absolutely vital to developing countries. And this is one of their motivations, I believe, for why they often would vote in favor of Chinese and Russian arms control proposals that we knew and they knew were fundamentally flawed, because they wanted to be able to take a stand for their self-interest, which was that space be sustainable and not be harmed, because they would hurt as a result. So first, in some areas like the ITU, developing countries and US space interests have a high degree of overlap and has worked out great. In the case of arms control, I think the developing countries have been looking for something that they could support that would actually be practical and move forward. And maybe we're seeing some of that in these behavioral-based items. You can't beat something with nothing, as the old, DC aphorism goes. And I think there's also a merit in them becoming more capable of engaging in these discussions. In the case of the long-term sustainability, I have to say, and trying not to be too undiplomatic here, that our Latin American colleagues didn't initially have engaged in a way that I thought was really effective, because they really didn't know a lot. And it was after a lot of work with NGOs and their own efforts that they organized themselves, and the group of Latin American countries became better and better each year that we went by, so that when it came time to actually put long-term sustainability guidelines across the finish line against Russian opposition, it was a group of Latin American countries that had become very invested in this process by this point, were fairly skilled, didn't agree with them on everything, but they became very invested in the process, and they really played a crucial role in pushing across the finish line. So I think it's in our interest in multilateral organizations for developing countries to play a strong role, if they in turn are willing to do the homework necessary to participate, and we have a frank discussion of what each other's mutual self-interests are.
Great, thank you very much. Therese, I'll put this next one to you. So our questioner asks, how far away are we from manufacturing satellites with facilities in orbit? And in addition, when it comes to all these sort of derelict satellites, is there any consideration for a right to salvage? Is there a potential to recycle and reuse these very expensive pieces of garbage, or is this questioner 50 years too early on the question? And of course, Jessica, Scott, if you want to chime in on any of these, please do.
I think that's a great question. I think we're still relatively far away from the actual manufacturing satellites on orbit, but there is a company, Redwire, that's been working on 3D printing on the International Space Station for a while. So hopefully technology like that will continue to develop, over the coming decades, so that we get to that point. But in terms of derelict satellites, the right to salvage is a really great question. So we recently had our first on-orbit satellite servicing. It was done on an Intelsat satellite, and it was a life extension mission. So there are companies investing in these new life extension technologies where they can either be refueled or tugged to another location and just kept on orbit longer. There's also, some interest in salvaging spent rocket bodies that could potentially be used as refueling stations. But the actual right to salvage piece is a legal issue that's very complex because there's no, without some sort of agreement between the owner of the piece of space junk, I'll call it, that's up there. There's no mechanism legally right now for someone to go and say they want to clean up a piece of space debris if it's not owned by them. And I've heard that there was an issue with Russia internationally where they have a number of spent Russian rocket bodies that have been deemed, the most dangerous pieces of debris on orbit. But I was told that when Russia was approached with the concept of, being liable for these rocket bodies, their response was, oh, they were launched by the USSR and we're not the USSR, so we're not legally liable. But when it was implied that they could be salvaged, Russia was like, oh, they're actually ours if they're valuable. So it's a very complex legal area on that one.
All right, thank you. Great question. Jessica, this next one I'll put to you. So,
Hey, Courtney.
Oh, yes, Scott.
Sorry, I just wanted to jump on
Please,
Therese's comment. One idea that's come up has been to do a modification on implementation of the registration convention, which doesn't require redoing the registration convention itself, but would be a clarification by states on their interpretation of how they will implement the registration convention. And so you could have states make a notation that says that this vehicle or object that we registered is now no longer in service and is available to be salvaged, but we take no responsibility if anybody salvages it for liability. They would have to assume liability if they salvaged it. So it's a way of going to the registration convention, which already exists and the UN already has, and at essentially no cost, remove this legal uncertainty by simply marking it. Now, if a country doesn't want to be first or called out or whatever, one could imagine voluntary practices by countries with capabilities like Japan and the United States going in and saying, okay, here's a dead object, we're going to go retrieve it. In the process, we will notify the UN that this is no longer in service and available for removal. We will go do that ourselves, thank you very much. But others could do the same. So we could start a process, again, with like no money up front, of simply creating a more defined addressable market for active debris removal. And if we would do it, try to pressure other countries like Russia and China to make similar markings on their systems. Either they can retrieve it themselves or allow others to do it. Because if we were to remove a few of these fairly large objects that have a large amount of mass to them, we would make a very, very big progress toward pushing back any sort of Kessler syndrome by removal of these large mass objects. And so I'm saying there's existing international law that we can do. Wouldn't be full salvage law or admiralty law, but it would be a micro step that the UN could do now with relatively low cost. Over.
Thank you. Fascinating. Jessica, I'll put this next one to you. And again, please chime in if either of you have comments. So the questioner wants to know, regarding companies posturing to be the global communication provider, maybe this might be more for you, Therese, too, by launching very large numbers of small satellites into LEO, which I believe is lower Earth orbit. Is that correct? Am I getting my terms right? Who is to say enough is enough? So I think there's almost two pieces here. There's sort of the who's in charge of saying how much is enough. And then, if we want to get a little bit more in depth on who's really jostling and jockeying for putting large numbers of small satellites into LEO.
Yeah, that's a really complicated answer. And I think you're going to get some better specific information maybe from Scott and Therese, but from a big picture perspective, there isn't really anyone to say enough is enough, because outer space is a global commons. It's not ruled or regulated from a single authority, and it's up to states themselves to regulate and authorize private industry that is registered in their countries and how they behave. There's probably physical limits. We don't know what those are, and I'm not sure we want to reach them. Certainly, which Scott would know much more about this because of his time at the ITU. But there are natural restrictions about access to spectrum so that your satellite is able to transmit the information that it needs back to Earth, and processes to regulate that through the ITU. But I think this is part of the challenge. If it's up to every individual state to say enough is enough, but there's a little bit of a competition to make sure that maybe companies from your own country are leading the way and providing amazing services, it's tricky. And so it's not just the United States. China's authorizing constellations, European states. Canada has authorized a few smaller constellations, but it's sort of a question of where does the party end? And normally, the market tells you when enough is enough. I was going to think of a horrible example here, but I won't, in Waterloo. But sometimes there's just too many corner stores or too many of a service to survive, and some of them go under, and the market has spoken about when enough is enough. The question is, can we afford to do that in outer space, or do we need to cooperate a little bit more? I think the focus on global service, though, is really important, because it means that not every country has to have its own constellation of satellites for the essential services to be viable, and thinking about, I guess, whose needs are being served and are we meeting them adequately might help in one way to move forward. But I think Scott and Therese would probably have more specific information on that.
Well, I could take a shot maybe, and then Therese can comment. First of all, this is like not new. We went through something like this in the late 90s when Iridium and Globalstar and there was a whole series of LEO constellations came on board. There was a proposal from Microsoft for 840 satellites, which we thought of as astonishing back then. And one of the reactions, however, was the ITU was overwhelmed dealing with all these paper filings that all had to be coordinated with each other, and it was quite a mess. And so there was actually a bureaucratic kind of counter reaction to how do you deal with all these paper satellites and coordination of them and so forth. One of the reactions, though, by the United States by the FCC was to impose a lot of new disclosure restrictions, milestone requirements in the early 2000s. Which we used to term the Fcc Unemployment Act, because essentially what it did is it shoved a lot of U.S. filings overseas. They fled overseas. So the FCC was trying to do something good, which was cut down on the number of paper satellites. But what the U.S. companies saw was increasing license fees, increasing bureaucracy, having to disclose proprietary information, and so they went to the UK, they went to Luxembourg, they went to Norway. There was an operation in the Dutch Antilles. I mean, and so it later went away, but the regulatory reaction was really rather interesting. I think that what we're probably going to see is some combination of both national regulation, which is the only thing you can really enforce, combined with multilateral voluntary guidelines. So we'll see discussions of guidelines in the UN, and then we'll see that translated back into national law and enforcement, which I think there ought to be more of a conversation between our telecom authorities, between ourselves, FCC, Ofcom, Norway, Luxembourg. Just as there is a small number of launching states, there is really a small number of licensing states. So China is going to be one of them, and Europe and US are going to be others that we need to get together on best practices and how to do coordination, because otherwise I assure you the ITU will just be overwhelmed and will kind of grind to a halt, and we'll lose the benefit that we get from the ITU if we don't do some pre-coordination among the telecom authorities up front. Over.
I just wanted to quickly add on the FCC front. So if you are a satellite operator and you want to downlink in the US, you need an FCC license. So the FCC has taken up orbital debris as a major issue. And they're in the middle of a rulemaking right now on orbital debris, where if you want a license in the US, you will have to follow, well, they're trying to say if you want a license in the US, you'll have to follow whatever the FCC orbital debris requirements are. So there's a chance that a good number of operators, assuming they want to provide services in the US, will have to follow whatever the FCC's rules are. There are certainly, companies in other countries that we'll have to coordinate with, like Scott was saying. And as Scott mentioned, I think there will certainly be some mergers and acquisitions of these companies. So I don't think all the many thousands of satellites that have been proposed today will necessarily end up being operational.
Great, thank you. Great to have all your expertise on that. Scott, this next questioner wants to direct this one to you. They're asking about, they're saying China and Russia, they're achieving significant space capabilities and space security. What do we expect from the US to maintain that balance of power and avoid some of the conflicts on land escalating into space?
Well, I'll go to what Jay Raymond has often said. There's no such thing as war in space, there's just war. And it may include the space domain or it may not. So it's not really separable from other domains. I think that that space policy and deterrence language there spells things out fairly clearly. There's a couple of elements to it to ensuring stability. The first is attribution. This is where we need space situational awareness to know who's doing what, because if you don't have that, you don't know anything. The second is that you be able to signal each other. And this is where norms are important. We need to be able to say this is okay behavior or not okay behavior. This is concerning. The Russian launch of kind of their Matryoshka doll, where different things started coming out and out and out. Nothing illegal about that, but we did say publicly that this was a cause for concern. So we should be able to say to people when we have concerns and when we don't, because that's the beginning of norms and signaling. Next, we need to have greater resilience. Weakness is provocative. If you look like a cheap and easy kill, that creates instability. So we need to have satellite systems that can continue to provide functionality, even in a jamming or challenged or a threat environment. And so there's been an effort over multiple administrations to improve resiliency of US space functions, because that increases stability, just as it does in the nuclear realm. Then we need to be able to have capability that's credible. So we need to have both doctrine, policy, exercises, and equipment that people look at and say, okay, that's not just paper, but they actually know how to use this stuff, and there's a credibility behind it. And then finally, fifth is that we be willing to have cost imposition. Cost imposition can be everything from sending a démarche saying that was bad, to economic sanctions, to use of nuclear weapons. It's the full range of cost imposition has to be there. And so all of those elements are being pursued in varying degrees. This is why you see SSA, why you see norms, why you see resilience, why you see talk about cross-domain operations and countermeasures. That by doing all these sorts of things, what you want to do is convince a potential adversary that today's not the day to do that. You know, let's just be calm and kind of get along and nobody make any sudden moves. And preserving peace and stability is something that's really hard. We work at it every day in the nuclear realm. We're going to have to work at it really, really hard in the space realm. And that includes a variety of tools, including norms, possibly agreements, like don't create long-lived orbital debris. But there's no single magic solution. There's a whole bunch of things that all have to work together to make sure the environment stays calm and peaceful.
Thank you. Therese, we have one question that's kind of technical specific on numbers. So how would you break down satellites by category? Like what percentage would be communication, surveillance, scientific exploration? What are the major categories you're looking at, and what's the rough breakdown of what you see in space? And I'll just add to that, how is that shifting?
Yeah, absolutely. So I've got a chart right in front of me that tells me all of those numbers. So 48% of the satellites on orbit at the end of 2020 were commercial communication satellites, and we're going to see that number greatly increase as the non-geostationary communications constellations keep launching, since those constellations, can be thousands of satellites. 20% of those were commercial remote sensing satellites, and that's an area that has also grown a lot. Because there are a number of satellite operators that are launching CubeSats. They're 10 by 10 by 10 centimeter cubes, often stacked in threes. So they can do things like take 1 meter imagery of the entire Earth daily. And those have grown a lot in both optical and non-optical regimes as commercial actors continue to expand. 11% of the satellites were R&D, 7% military surveillance, so your traditional spy satellites. 6% government communications, 4% navigation, and 3% science. So that's the overall breakdown.
Thank you very much. Jessica, I'll give this next one to you. So the questioner says, you also see a tension today between US company innovation trajectories and regulatory clampdown, such as shutter control options on imaging satellites and limits on imaging satellite revisit rates, benchmarked against the capabilities of foreign peers. Can that trade-off between fast innovation and national security ever be balanced in a way that's acceptable to everyone? And if not, where does that balance lie?
Ooh, that's a tricky one. I will admit that I saw the articles about the new restrictions on revisit rates for remote sensing satellites, and I didn't dive into the details.
And could you, sorry, just for those of us who aren't as up to space terminology, would you mind just clarifying what revisit rates are, or any terminology that we should know?
So Therese is probably better situated on this.
Okay.
She works with the commercial industry. Do you want to take it, and then I'll add on after you?
Sure. So the issue that US companies have had, particularly in the remote sensing sector, was one, for a long time, it was very difficult to get a remote sensing license for new and innovative technologies. And there was commercial remote sensing regulatory reform that was sort of pushed through about a year ago, I want to say. But an issue that's come up recently is that NOAA does commercial remote sensing licenses in the US, but they sort of do it in this group in consultation with the Pentagon. And you can imagine there's a series of commercial and national security trade-offs. So the things that have come up very recently is interest from the Pentagon in limiting how often you can image certain areas with commercial satellites, or the shutter control is, you can't image certain areas where there might be like critical national security assets from the US. And there's a lot of concern that with all of these constraints, operators have already moved internationally dramatically in the remote sensing sector, particularly prior to the commercial remote sensing regulatory reform. And there's a lot of concern that if they impose these limits, then operators will continue to move abroad with these very restrictive capabilities. And Scott may have information to add as well.
Yeah, sorry, let me sort of add on this. Yeah, we did a major reform of remote sensing regulations, and we shifted away from trying to define certain technical points, and we really looked more at a market-driven point. So if something was broadly available in the market already, there's no reason we should limit US companies. If only a US company offered a capability, then maybe there'd be some restrictions. And if somebody was offering something that was absolutely unique, okay, there might be even more restrictions. You might be limited to selling only to, the US government. But the idea was to make sure that we didn't limit companies unfairly or without effect. The resolution, temporal resolution being talked about is analogous to spatial resolution. We went from looking at here's, 1 meter and then half a meter and then a couple centimeters kind of thing. Well, similarly with temporal resolution, it's like, do you take a picture once a week, once a day, once an hour, once every 10 minutes? And you can look at change detection with temporal resolution, which has commercial as well as dual use applications. I'm a little more than a little irritated, I think, with some of these restrictions being put back in, because I think they tend to unfairly limit US companies, and they also tend to be a distraction from the DoD and the intel community doing what it needs to do for force protection. I have no disagreement that bad people can do bad things with this information. Absolutely true. We had similar debates in GPS. There used to be a thing long ago called selective availability, which intentionally dithered the signal of GPS to being no better than 100 meters. You can imagine that. And good reasons at the time for doing so. But we concluded that we needed to get rid of that because, one, people were working around it anyway, and then two, by keeping it, the DoD was able to kind of remain in denial that they needed to work on countermeasures for this new world. And I think we have a similar, not exact, but a similar situation today, where by thinking that we can impose these restrictions, we really just hurt US companies, and more, and kind of worse, we allow people, particularly in parts of DoD, to remain in denial about the need for force protection and the need for other countermeasures, camouflage, moving. It is a more globally transparent world, and that's a problem, but you're not going to get there by unilaterally handicapping US industry. End comment.
Yeah, and this isn't a new issue as well. Similar to some of the other things we've been talking about, there have been issues to block the use of satellite imagery over sensitive parts of the world for decades now. And that's, I guess, what I find surprising is just that the cat's kind of out of the bag. There's lots of different service providers regulated by different countries. You can go to Google Earth right now and you will see there are certain spots that you cannot see. I have colleagues who have been trying to look at certain areas of Russia to see what some of the Arctic installations look like, the pace of building, and it's blocked out, but you can buy that commercially. And so I guess I agree with Scott that it's sort of an odd approach to a different problem. The problem has changed, I suppose, and we're kind of falling back on old ways of dealing with it in some cases.
The problem is even older. It's I don't want to be blamed if something goes wrong. So I'm going to do everything I can to making sure that I tried to stop it, but I couldn't be helped and I can't be blamed, rather than this is dangerous. I got to figure out how to operate in this environment, you know. Otherwise, it's really easy to reach for the bureaucratic card as opposed to doing the operational card.
Well, unfortunately, we have to end there. But Scott, Jessica, Therese, thank you so much. This was a fascinating conversation, very outside my realm of normal conversation, but one, you know, an area that is clearly growing in importance, and we'll just see that more and more, I think, as time goes on. So thank you so much for cluing us into what we should be paying attention to, and what to be looking for. So, and thank you all who joined us today. Really wonderful questions, much more than I could have done on my own. So thank you very much. Our next briefing is, we'll actually be looking at the Pandora's papers. And that is on Tuesday, November 16th, and that's from 12 to 1 Eastern time. So please do RSVP. Feel free to invite a friend or a colleague who might be interested. We'd love to have more people join us. So Therese, Jessica, Scott, thank you so much. Everyone have a wonderful day. Bye-bye.
Thank you.